So now we can get started. Sorry for the delay. So here's your 5-well cross section from well number 2 to well number 6. And each one of these black vertical lines was a core that was taken. So every well was cored. But not every well has sand in it. And what you see here, I've highlighted in for you with that new PowerPoint I gave you, the sandy intervals. So the red line like here is the top of the reservoir sand, and here's the base of the reservoir sand. Top reservoir sand, base, top, base, top, base, and top and base here. So those are your reservoir sands. And this is a stratigraphic cross-section, so I have a stratigraphic datum, a shale, that I know correlates across all of these wells. Now, the question is, again, why are you getting such an odd distribution of oil and gas in those wells, and what can you do about it if you want to do any infill drilling or anything like that? So the first step in answering that question is me to tell you that this is an incise valley deposit, and so the base of the valley is the base of the reservoir sand. And I'm going to show you, I'm going to do that one for you here. So the base of the reservoir is the base of the sand. But notice that this is a nice blocky sand on the log, nice blocky sand, and a blocky sand there. But this one isn't in well number 2. It's kind of a dirty sand, not so sandy, and it kind of cleans up a little bit. So it doesn't have the same log shape or log characteristics as these other sands. And so what we indicate by that is that incise valley is actually coming up over the top of this sand, and that actually this sand here is an older sand, and you have the younger sands inside the valley. Just like I showed earlier. Use this one to show where we had this nice this cleaning up pattern that turned out to be high stand deltaic rocks, and then you had your incise valley, and then your incise valley fill giving you a blocky log pattern. So what you see in this cartoon is pretty much what you see there. So we can safely put the base of the incise valley here. These are all fluvial deposits, by the way. Incise valley fill fluvial deposits. And we can say, remember, this was the deepest well, or the deepest well, but it's got gas, 300 MCF of gas per day. And then when you get up here to well number 3, you're now in an oil leg. So you've got a reverse situation, and because of why that is because this base of the incise valley, an unconformity surface, is a surface that has a soil on top of it. So you had a drop in sea level, a soil for a period of geological time. You had a kind of a muddy soil develop on it, and then you had backfilling with the sand, with fluvial sand. And so that boundary here is really a permeability barrier. So you've really got two reservoirs. You've got a gas reservoir that is older and then you've got the younger Incise Valley Reservoir. Now, the question I'd like you guys to do, keep your blood flowing after lunch and all the delays and everything, is to correlate these sands. Okay, now again, this is a stratigraphic cross-section where I have a shale that I know is the same shale, but what you see is the sands are at slightly different elevations, or depths, I should say, not elevations. So why don't you spend about 5 or 10 minutes, for those of you who have computers, I don't know what you'll do without a computer, you can't really do this, I guess, but spend 5 or 10 minutes correlating those sand bodies. The reservoir sand is what you want to correlate. Okay? Wake up. There's the top of it. Okay, so you've determined that you have a compartmentalized reservoir. Okay, now you have this diagram in with your PowerPoints, and what we did in the previous example part was the stratigraphic part. We still didn't get our answer, so now we want to put in the structural aspect of this reservoir, because remember that as we went from well 2 to well 6, we were going shallower and shallower up dip. So now why don't you spend just a couple of minutes and put your correlations onto this structural cross-section. Okay, now you did the stratigraphic correlation. Now put the stratigraphy into a structural cross-section. So spend a few minutes doing that, and then see if you can answer then why you have the distribution of oil and gas that you do. Okay? So just kind of transfer your correlations to that structural cross-section.
Luego lo inclinas a los flashes. Todito selecciona apenas. Hazlo girar, hazlo más.
Números 3.
Esa creo que tiene, no, es uno, ¿no?
Sí.
Es más chiquito.
And don't forget to put in your the base of the valley on your structural cross section. Make sure that that's on there as well.
Ahí,
Este residual no. 5 y 6.
4 y 5. 14 hace 5 y
Se
5.
movió. Sí, de ahí estos dos botones. A ver, pero.